Good evening, everyone. We're going to get started here. Just to get started quickly, my name is Eric Eberhardt. I'm the director of the Geological Engineering program, and so I'd like to welcome everyone here, our students, our colleagues from industry, our colleagues from the Vancouver Geotech Society. This is one of our key events in geological engineering each year. This year, we have the privilege of having Dr. Anthony Hodge to speak to us today. And you've seen his bio and his title. But just to sort of go back in terms of some of the history of this event, this is our 19th edition of the Geological Engineering lecture. And you can see, of course, we have a long list of distinguished names of people who've come and spoken at this, going back to when we initiated this event in 2004 with Nordy Morgenstern. So this is one of our key events, and each year we ask the geological engineering students, we ask the GeoRocks Club, what is the topic that you think is really important to you in your class and that you would like to hear someone speak on? And of course, what you're going to hear tonight is with what's in the news. When we talk about the green energy transition, we talk about critical minerals, we talk about the copper supply gap. There's a lot in the news in terms of the tension between mining and what some people think is the environment, and really bringing that together where mining is on the front line in terms of the energy solutions that are needed for climate change and the green energy transition. And so we thought, who better to speak than one of the experts on this topic, Dr. Tony Hodge. And what is unique is Tony's actually an alumni of the Geological Engineering program. We don't actually target alumni with this program, or with our distinguished lecture. We talk and we target people who are the top speakers in their field. And so that's what makes this special, especially as we've just celebrated the 100+1 year anniversary of geological engineering. I think it's really fitting to tie all this together with one of our alumni who's coming back as a distinguished lecturer. And for that introduction, or first to say a welcome from the GeoRocks Club, I'll call up Adrian Tam.
I'd like to give a special shout out to VGS for sponsoring this event, for all the food and all the drinks we had just now. I'd also like to conduct the land acknowledgement. So we are on this course is held on the UBC's Point Grey, Vancouver campus, which sits on the traditional, ancestral, and unceded territory of the Musqueam First Nation.
It's my pleasure to provide an introduction to Tony Hodge. You know, when I've seen a change in the students, and Eric kind of alluded to this, in that when I was a young engineer, people wanted to go out and be an engineer and do engineering stuff, and which is all fine. Now I think people have they want more of a sense of purpose and, you know, a broader connection to society. And I think as you hear this introduction for Tony, you'll see that he was at the vanguard of this. And his career really marks a person who's done that and followed a very interesting path. And so it's 50 years since he graduated in 1972 in the GeoEng program. First, he did work in groundwater and geotech engineering. And if you look up his paper, he's got some amazing flow nets. So all you people in 429, you can look at what Tony did there. Really great stuff. Then he worked in North and Central America. In the 70s, he was the director of the research of the Royal Commission on the Environmental and Health and Safety of Uranium Mining here in BC. And actually, I had a student look at the uranium deposits in Summerland. So these peak deposits that were containing uranium. Then in the 80s, he took up residence in the Yukon, where his interests went into environmental advocacy, energy policy, regional water management, and the northern benefits of resource development. So starting to get more of that societal impact. He coordinated the development of Yukon 2000, a long-term economic development strategy. You know, engineering problems, you know, the economics is hugely important, and that's a societal consideration, jobs, etc. Then in the 80s, he moved to Ontario, where he's the principal researcher of the principal Canadian researcher of the U.S.-Canada State of Environment Review of the Great Lakes ecosystem. So that's kind of moving far from geological engineering right there, which is great to see. You get your portfolio as water, yeah. Then he was elected president and chair of the Friends of the Earth Canada, and appointed a member of Prime Minister's National Roundtable on the Environment and the Economy. Then at the same time, I guess you were doing your PhD at McGill, which you finished in 1995 in interdisciplinary studies, assessing progress towards sustainability. This is, I think, quite a bit ahead of the curve in terms of sustainability. UBC sustainability became one of the major principal focuses, I think, in like 2015 or 20. So you're way ahead of the curve here. Then he returned to Victoria, worked in private practice. Then in the early 2000s, he led the North American component of the international project on mining, minerals, and sustainability, and then sat at the core of which sat at the core of the Global Mining Initiative. And that was a program to look at the agenda for changing mining, aiming at synchronizing mining, industry, and societal values. In 2007, he was the first Kinross Professor of Mining and Sustainability at Queen's University in mining. But then a year later, he was poached to go over to the UK and became president of the International Council on Mining and Metals in London. And he remained there until 2015, 7 years. So now he continues to write and speak on applied sustainability related to mining. And his current focus is on how to bring strengthened societal and environmental performance across the global mining community, how to address the tough issues of mine closure and post-closure more effectively and efficiently, and how to develop methodology of contribution analysis using a retrospective full life cycle analysis of Yukon's ferro mine, which is a huge problem. He's currently an adjunct professor of mining at Queen's and at the Sustainable Minerals Institute in University of Queensland, two Queen's places right there. And he's a member of the Natural Resource and Energy Leadership Council, convened by Resolve in Washington, D.C., and board of director of EcoSmart Foundation here in Vancouver. So, super accomplished guy, and a very, you probably have a couple of novels in you there in terms of all the different places you've been and things you've done. So without further ado, though, I'd want to welcome Dr. Tony Hodge as our 2023 Distinguished Lecturer.
Thank you very, very much. I too want to recognize the fact that we are on the traditional, ancestral, unceded territory of the Musqueam people, where generations have lived now, will live in the future, and I honor all of these and the land that is their home. I was born here in Vancouver, but my ancestors arrived from the UK in the 19th and 20th century. And I know that we have much to learn from the First Nations, and I hope for an increasingly respectful sharing as we walk together forward. Let me just get organized here. Change. 50 years of change in the industry. I take that 50 years not because of the 1972 completion of my first degree here, but because it's a turning point. It's a significant turning point because the world came out of the Second World War and it exploded in interest to rebuild a world that had been broken. And by about early 70s, it had reached a peak in that effort to rebuild the world. Just before that, about 1963, a book came out in 1963. An author came out with a book that alerted the people to the effects of the chemical pollution on the songbirds in the east coast of the US. It sparked and marked the arrival of the environmental movement, which I would in due course become very, very deeply involved in. So 72 is not a bad time to start. And when you look at the mining industry in the 50 years since then, it has experienced astonishing change. And I mentioned that because one of the difficulties for the mining industry, the mining industry struggles with when you speak to people in the mining industry is they say, just tell me the rules. I don't want them to change. Tell me the rules, give me stability. Doesn't matter what the rules are, we'll figure out how to work with them. Tell me the rules, give me stability, and we can move forward. And one of the messages is that the rules are never going to be stable. They are always going to change. The kinds of things that have changed in the last 50 years, let's listen to this, within the mining industry. Of course, there's been a move to much larger open pit operations. There's been gains of economies of scale. We've moved to larger, lower grade operations with significantly larger tailings facilities as a result. The digital revolution has turned mining upside down in terms of how it operates now. The center of gravity of mining has changed. The old European center has given way. Emerging countries have come in. China's a power in mining now. All big change. The market has changed with that. The mining industry has tried to adjust to evolving societal values, and I'll talk a little bit more of that in a bit. The structure of the market has changed. There has been across the world growth in understanding of the implications, not just of mining, but of human activities. Eric said something quite interesting about mining being on the edge. Mining is on the edge. It's on the edge in several ways. It's on the edge because most mining activities are at the periphery. They're not in the middle of Vancouver. They're at the periphery, where the environmental implications are there for everyone to see. And they're often out in wilderness areas where communities are small, often First Nations people. So it's at the human ecosystem interface more than almost any other industry. So you can see it. And that was something that when I was very involved with the environmental movement, we were aware of. Listen, most people in Vancouver don't know what an open pit looks like. If you want to scare them, show them a big picture of an open pit. So that's something that the world is aware of. But the mining industry is out on the edge, but it's out on the edge in another way, which is a message that I want to share with you. A lot of things that the mining industry is dealing with a lot of things that they're dealing with are tough. And what mining is faced with resolving, other industries and other parts of our community are not having to face. Whether they like it or not, the mining industry is therefore in a leadership position to deal with some of the issues I'm going to talk about tonight. And it can either resist, which a lot of it does, and it's because they don't see that leadership position, or it can embrace it and opt to find creative solutions and make a real difference in the world today. I really don't understand why that part of all of what I'm going to talk about is not understood more and reflected more. Mining industry is very defensive. I sat in a council in London with 20 CEOs from some of the largest companies in the world. On negotiations with labor, they're tough. On negotiating with each other, they're tough. But when it comes to dealing with societal stuff, they're the most thin-skinned pussycats that you can possibly meet. They are really sensitive. I watched Peter Monk, who former head of Barrick, sit in a meeting with a bunch of environmentalists. And he said, I don't know what you guys are all about. I'm just a poor miner. I just want to do my job. Why don't you just help me do my job better? That's all that I want. But I tell you, it's an astonishingly amazing phenomenon to see how bruised the mining industry gets when bricks are thrown at it. But it doesn't need to be that way. There's no reason to be defensive about things. I think it's that attitude is itself an impediment to and a contributor to the tension that exists between mining and the rest of the world. Other important changes that I just quickly mentioned: recognition of the rights of Indigenous people. When I was at ICMM in 2013, we passed a policy statement on free, prior, informed consent. We were the first industry to ever deal with that. The mining industry could take credit for that, but you don't hear about it. It's not an easy issue. It's a tough issue. But the mining industry has made a big difference. Civil society in this 50 years has exploded in importance. New players. This is all part of the operating environment of mining, which has changed in the last 50 years. The role of, in the process of all of this, is really reflecting the change in societal values that in due course will lead to changing law and regulation. The ferromine that was mentioned that we're doing work on, which I'm giving a talk about tomorrow, by the way, here on campus. The ferromine was designed in 1967-68. It was operational by the end of 69, started production in 70 and operated till 98. There was no Environment Canada when it started. There were no environmental regulations in the country. Indigenous people were not part of Canada's constitution. The change has been astonishing for the mining industry to deal with and to respond to. And everyone in the mining industry, I think, is struggling a little bit with some of these changes. And then today, final comment on change. Well, there's the chaos of the war, which is has once again turned everything upside down, and nobody knows where it's going to lead. So here we go. I'm going to talk about sustainability and sustainable development and what that means, and take you through a bit of a story. This is part of the story that very few people really understand. The idea of sustainable development was popularized by Gro Harlem Brundtland, who became the chairman of the Brundtland Commission, or the World Commission on Environmental Development. People have come to understand this idea of sustainable development, three-legged stool, environment, balancing environment, economy, and social concerns. It's not a conceptualization of it that I'm comfortable with at all. But look at the origins of this. Brundtland was actually the third international commission. The first commission was chaired by Willy Brandt, then of West Germany, and it was on north-south inequities. How does the world deal with the imbalance between emerging countries and developed countries? The second one was chaired by Olaf Palme from Sweden, and he was looking at how do you enhance international security. The Brundtland Commission had 22 members. It had Russia, China, Brazil, India, Canada, the US, Sweden, France, the UK, an astonishing group of people. Brundtland, after their work, that they had hearings all over the world, they opted on this idea of sustainable development that would be a way forward for humankind that enhanced security and reduced the inequities between the North and the South. Now think about that today in terms of what's going on with the Ukraine, where we can't talk to the Chinese, we can't talk to the Russians. We've got a little club over here on the West doing stuff, and a big club or a little club over there in the East doing stuff, led by Russia and China. It's astonishing change since the mid-'80s when this was done, when we were coming out of the Cold War, when Gorbachev, and I just read this a few days ago in preparation for this, the Russian member of the Brundtland Commission initially had a KGB officer with him every meeting he went to. When Gorbachev came in, he immediately stopped that and turned around and invited the Brundtland Commission to have their second last meeting in Moscow. Well, the Brundtland Commission said, well, that's fine, we'll come, provided our meetings are all open, our agenda is made clear, we broadcast everything freely. Gorbachev agreed to that. There's a massive change going on in Russia. That's the origin of this idea of sustainable development. It's a profound concept. When I went back to do my PhD, the first thing I did, you mentioned the Great Lakes work. The Great Lakes work that I was involved with was led by Jim McNeil, who had been Secretary General of the Federation. That's the connection. And there are always little connections. When I went back to do my PhD, the first thing I did was to try and understand whether or not this idea of sustainable development was a flavor of month thing. You know, published in the Harvard Business Review, like there are a lot. ESG and responsible mining, those words are kind of flavor of the month words. They're here right now. They'll disappear. In my view, I think they will. What I convinced myself by reading stuff at that time from all over the world was that it represented something significant because it represented a new set of values. That's at the heart of this, and I'll come to that. These are the definitions that I work with now, just very, very quickly. Most of my slides don't have words on them, as dense as this, but sustainability is an idea that is the persistence of certain necessary and desired characteristics of people in the ecosystem over a long period of time. Now, the problem with that is that necessary and desired are value-based. So what you would suggest is necessary and desired might be different than what I think. The concept of values is entrenched throughout the idea of sustainability, applied sustainability. And development, the way that I take it, is not growth in terms of physical growth, but rather to expand or realize the potential of human development. Bring gradually to a fuller, greater, or better state. That's how I think of this. And sustainable development is an ongoing process in which we are responsible for our actions. We take actions leading to development as gradually to a fuller, greater, or better state that meets our needs today, but doesn't bugger things up for the future. That's the concept. It's an elegant concept, and it represents a shift in values that has got to do with not just being centered on a human society, but reflecting the fact that the environment that is our home around us has to be part of what we respect and care for as much as human society. It's an interesting idea because if you think about it, it's not complex. If we do stuff that's really good for people and we deep six the environment, it's not going to be very good for us. But you know, equally, and this is the other side of the equation, if we do stuff that's fantastic for the environment and thousands of people die, that's not helpful either. It's a two-dimensional, in engineering terms, design criteria. That's how I think about it. And when you apply it in that way, it's very, very interesting. Two quick cautionary notes. Oops. There's a couple of really good quotes that I picked up through the years, and these are two. Unfortunately, although there's a high, hard ground where practitioners can make effective use of research-based theory and technique, the stuff of universities, there is also a swamp lower down in which lie the confusing messes incapable of technical solution. And it's in the swamp we find the problems of greatest human concern. Drug use in East Vancouver. And another part of this cautionary note that I want to add, hard and soft systems. Hard systems are systems that can be well described in mathematical terms clearly. They're really, really important. They're essential. They're the center of technological development. Soft systems are systems that you cannot describe very well in mathematical terms. You can't describe the drug use in East Vancouver very well. We can count people. We have to learn to deal with both of these. It's not one or the other. They're both really, really important. Hard systems have very well-defined objectives. Soft systems don't. But in reality, hard systems are a subset of the more general soft systems. And it's really, really, really important to think about. And particularly, I did my groundwater work with Al Fries, and I did a computer model of groundwater flow systems using the Laplace equation at base That's hard system approach, and it's really powerful. But there's other stuff in the world for which that doesn't apply. And I must admit, when you do computer modeling stuff, the greatest benefit is for the person who does the model. You really learn a lot. But there's danger too, because the model looks terrific and you really believe it. And a model is not the real world. A model is of the real world. There's a big difference, a big, big difference. Jim McNeil, who I worked with on the Great Lakes stuff, said this about sustainable development. Back in '87, we thought the concept was plain enough. We defined it in several ways: ethical, social, ecological. But there are two that were basic. First one to do with nature's limit. We don't want to endanger the natural system that provides support to life on Earth. Later, we pointed out that current forms of development drew too heavily on already overdrawn accounts of ecological capital. They could not be extended into the future with bankrupting those accounts. So he's using financial language to communicate with people, talking about the ecosystem. We further said that while we may show profits on the balance sheet of our generation, our children will inherit the losses. They may damn us for spendthrift ways, but they can never collect on our debt to them. I'm going to show you in a minute an accounting from the Farrell mine in the Yukon that I just finished 2 weeks ago. And it's going to show you the costs of closure that for kind of a freak reason we have been able to create and be confident about. And it's going to show you this debt that we're passing on to the future. Oops. I turn this around. So at the heart of applied sustainability is a very simple value set: parallel care and respect for people and the ecosystems. And just for those folks who will end up practicing here in British Columbia, note this from the EGBC Code of Ethics here in British Columbia. Registrants must uphold the values of truth, honesty, and trustworthiness, and safeguard human life and the welfare of the environment. They must hold paramount the safety, health, and welfare of the public, including the protection of the environment and the promotion of health and safety in the workplace. That's there because of this learning about sustainability. So from a systems perspective, look at, I drew this up. It's very simple. Human well-being, ecological well-being. These are ends that we try to achieve. Think about that two-dimensional design criteria that I mentioned before. We have certain things we can do to create that well-being. Mining is one of them. But what we forget is that in addition to market economic activities like mining and the creation of rules so things work well in a governance system, the G of ESG, there's all sorts of other non-market activities that are really important. All the work we do at home for which no one gets paid. All the volunteer work that happens in society. All the activities that people participate in. These are really, really important part of our well-being. And what we've learned is that in applying these ideas, there are three fundamental considerations. One is, it's not just about what we're doing, but it's how we do it. One of the things that the mining industry has been very, very bruised about is that oftentimes they will do things that they think are good, but they've never done it in a way that integrates their activity with the community. It's the process that breaks down. It's not simply the what. People in the academic community have created great plots of what sustainable development considerations should include. All the things that should be done, all the different actions that we take. But how a company interacts with people in the community to make it so that it is as much importance and of value to a community as it is to the company. It's the process that breaks down. So there is substance and process in every element of what I'm talking about. And we must not only look at the short term today, but also the long term. And I'll come to the closure issue, which I think is where it's where the rubber really hits the road in terms of mining. And you will see, I will be arguing for a form of engineering design that admits that we don't know everything today. And the only solution is for us to enter into a learning phenomena where we admit that we don't know, where the risks are great, and we put in place the engineered systems that allow us to move ahead, to recognize change and adapt to it before crisis occurs. And that's very different than standard engineering approach right now, which wants to provide a perfect solution now that will last. The problem is last how long? And most traditional engineering time horizon on design is maybe 50 years. Most buildings on campus here will last 50 years if we're lucky. Newer buildings are not lasting as long as older buildings. Bridges might make it up to 100. Tailings facilities that are having to deal with AMD have to last a lot longer than that. And how does that fit in traditional engineering design? Well, I won't stop on this, but it's another cut at how you get the bits and pieces. You can take that bubble diagram. It percolates down to being a very complex system if you want to push that way. I show this to you because in 2002, a group of about 20 of us, 25 of us, from industry, from environmental organizations, from government, from First Nations, a multi-interest group, said to ourselves, well, how, if you want to have all these lofty ideas, how the hell would you make it so that a company could understand whether or not they're contributing to sustainability in a positive way? What would you have to do? And this is what we came up with. It became known as the 7 questions of sustainability. If you look at these, they handle all of those considerations that I mentioned. First thing is engagement, relationships, process. Second is, as a result of what the mining activity is, will people's well-being, will the community, will the company, will the other organizations, will government be better off as a result? It's not just the company or it's not just the community, it's everybody. Is the integrity of the environment assured over the long term? Is the economic viability of the company assured? Is the economic situation for the community improved? Non-market activities, traditional activities. For the First Nations people, this is very, very important. Are the rules right, or should be the change? And then when you pull it all together, and we've stopped doing this, I know in the 70s, when Environment Canada was created, almost the first thing, and by the way, in the US, a little bit before that, the Council of Environmental Quality was created. It's some tremendous work on state of environment reporting. And they said, what are the indicators? How do we do this? And they drew together vast data sets and then tried to analyze what it all meant. By the late 80s, when computerization occurred and costs of synthesis were being recognized, the governments said, well, what we'll do is generate the data. Everybody can have the data, then we'll be transparent about it. We can all have the data. So there are reams of data out there, and nobody's pulling it together. What does it mean? We kind of forgot pulling the wisdom out of it. Oops, I will go back. So this is a really important drawing. This is the life cycle of a mine project. You can see the exploration on the left-hand side. And then there's a period of design and regulatory review and construction, where oftentimes the number of employees goes way, way, way up. and then it drops down, and then there's a period of time in operation. This shows a solid line. In reality, any mines have short-term stoppages for reason of economics, for reason of environmental problems, for reason of labor strife, whatever. There can be accidents that stop things. And then there's a period of closure, the blue one, and then there's post-closure. Closure is the period of time when you groom the site for the long term, when you put in place the needed facilities, take it into the long term as much as you need it to do. And then there's post-closure. And for some mines, post-closure goes on a very long time indeed. Now, the remarkable thing about this drawing is that the standard life cycle up until the 1960s, it really didn't take you past the end of operations. I did some work on a closed mine in the Northwest Territories in the early 1980s. And we went off way out in the bush to see this mine. And the mining company had simply walked. The bags of reagents were still there, rotting in the floor of the mill building. Nothing had been put away to bed. They just walked. The First Nations people were using the bunkhouses for overnighting on their hunting trips. There was some very nasty stuff around. It was a uranium mining, and there was radioactive problems. So it was only in the 70s that people started, after the Environment Canada's, the US EPA's, the equivalent in Japan and France or wherever, started putting in regulations. They started cleaning things up. And I think by that time, also people within the mining industry were recognizing this is important. Mining people are part of society too. Mining people also understand that these things have to be done. It was only about around the turn of the millennium that people began recognizing this long-term tail post-closure. That's only 20 years ago. Now, early talk about design for closure, not post-closure, but closure, was going on in the 80s. And some of that work was led here in British Columbia. And it's terrific work. And the concepts where they were saying, we have to think about closure from the start of operation. And look at closure and post-closure. There's no money generation. It's finished. So the operation ends, and all of a sudden you've got this massive tail of activity for which there's no income, and for which companies are ill prepared in a lot of cases to deal with. And that's a tough change in terms of change management for companies. I'm going to come back to this one a little bit later. Just very quickly, in addition to the project life cycle, there is also a product life cycle. So the ore in the ground, in terms of reserves, if that's what it's judged to be, goes into mining, and you get concentrates, and it's smelted and improved and eventually comes out in the consumer society. That's another part of this chain. And just for your interest, frustrated with the lack of movement in the mining industry as a specific strategy, the environmental movement came over to this and started working with the folks down here and that have these end products who drive the purchase of the concentrates way farther out there. So Apple, computers, some of the jewelry manufacturers and so forth, they are now demanding that there be demonstration that mining way back up here be done in a certain way, a way that reflects the ideas of sustainable development. There's a whole new pressure on the mining industry because all of a sudden their market is the people who are going to buy the concentrates from them. And that was a conscious strategy of the environmental movement to go in that direction. In addition to that, when you're thinking about effects of mining, they ripple out a long way. So here we've got the metal and minerals industry, and there are direct and indirect inputs that cause activity way upstream. There is action in the mining industry. Metal and minerals are produced, And there are direct and indirect outputs down there that lead to some contribution to human and ecological well-being, or not. But we don't know, because nobody's looking at that question. But it's very, very important, that ripple effect. What you do hear is the mining industry will say that for every job that we create in mining, there are 3 or 2 or 4 created somewhere else. But you know, it's bigger than jobs and taxes. And I have a frustration because you hear the mining industry talk, and they want to be given recognition for how they contribute to society. And what they say and articulate is that's what they understand as jobs and taxes. But jobs and taxes is not what most people are really thinking about all the time. Sometime, yeah. And not only that, I've lived in mining towns where the relationship between mining and the community has been wonderful. And the contribution of the mining company to that, it's got to do with other stuff. It's got to do with a father and mother having kids that are happy because there is a sense of security in the town. How do you measure that? There are communities all through British Columbia that have been successful small mining communities where people now go back there because they loved it so much. How do you capture that? It's not just jobs and taxes. There's something else going on here that we don't completely understand. So I want to talk about closure for a second, because these ideas that I've been talking about really come home to roost. And in the last 4 or 5 years, I've been working with a team of people. I'm working with a team of people on the Faro project. Faro project, very, very quickly, closed in 1998 because after about 30 years of operation, because it went into receivership after about the 5th owner. And for a while, they tried to sell it off to another company. That wasn't successful. So it's now in the lap of the federal government. And it's a very interesting phenomena. It went to a receivership. It's now being led by the federal government, an arm of the federal government. And because of the particular sequence of events, the data and the reports are all available. And that's very unusual. Most companies, they may keep the reports, to a certain amount, but when you're trying to look at the long term, it's very difficult to get that degree of insight. And in addition, there are still people around that witnessed this. You can talk to them, you can ask about them, miners, First Nations, people in the community, etc. But what I want to emphasize here is that in the sustainable development world, I'm afraid to say that here at UBC, it's not about sustainable development and mining. Almost always, what you hear of is what we need to do different during the operational phase. That's important. We need to use less water. We need to use less electricity. We need to learn how to grind more efficiently, because comminution, the grinding phenomena, is a huge contributor to greenhouse gas emissions across the world. I think it's 3% from comminution. Not all mining, but one big bunch of mining. There's lots of things in the operational phase that we need to do. But it's in this long tail of closure and post-closure that we really need to do things differently. And one of the problems is, or perhaps maybe even the major problem, is that we don't think long term. Politicians think of election cycle. Communities, Indigenous people, maybe they think multi-generation. Some do, some don't. Investors are working on a quarterly report basis for the most part. And we're talking about how do we deal with problems and issues that are centuries. We're not very good at that. It's just not part of our habit. The investment, actually, interestingly, the CEOs of the large mining companies, they do think multi-decade. They have to keep the supply line going for their projects. But the vast majority of people are short-term. And our economic analyses, I'll show you in this next set of slides. Our economic analyses drive us to short-termism. So these next slides are going to tell you about the costs of closure of the ferromine in the Yukon. We were able to create a profile of the full expenditures of the federal government to this project, starting in the mid-60s to today, and then we projected it out into the future to give you a sense of what the relative value, the relative expenditures have been in this mine. So we know that for the ferromine, documented historic expenditures are in the order of $2.4 billion. Now, ferromine's don't let that scare you. It's a big mine. I picked up a comment somewhere, and I can't find it, which I'm irritated about right now, but at one point, 1 in 5 Toyotas in Japan were being made with some contribution of metal from the ferromine. At its day, it was amongst probably the top 3 sized mines, lead zinc mines, lead zinc silver in the world. It was a big operation. At its peak, the GDP of the Yukon was probably 40% or 50% dependent on the ferromine or more. It had a huge impact on the Yukon. It was very, very hard on the First Nation that were affected by that one. But it's not without trying. In 1967, the federal government and the company signed an agreement. And one of those aspects of the agreement was to provide employment opportunities for First Nations people. It was too early. It's like an impact benefit agreement through 30 years ahead of its time. And the cultural divide between First Nations people and non-First Nations was so big that it never worked. They never met any of those targets. And there was some very, very, very unfortunate stuff that happened as a result. So right now, this project is in regulatory review. They look ahead and they've got a 25-year period of closure where they're going to groom the site and do stuff. And they estimate right now that it'll cost about $1.2 billion over the next 25 years. So here's where it gets interesting. What happens after that? You've got a very, very large tailings facility and waste rock dump that's sitting there. They're going to cap it and stabilize it. That's the option that was chosen. Well, if you use economic analyses, which is standard industry practice, you use a net present value calculation. I don't know how many of you are familiar with that, but depending on how you craft the net present value calculation, it causes this number to explode to a huge number or diminish to nothing. Well, it turns out that if you use a 3% discount rate, it's called, for this calculation, that whether the time horizon is 500 years or 1,000 years, it actually doesn't matter. Because the effect of the way that the economic systems work, that discount rate causes the future value of money to diminish until about 100 years out when it disappears. So whether you got a 500-year time horizon or a 1,000-year time horizon, you still got $172 million of pot, which is what in the documents before the regulatory review people put down. So if you use that number, you get about getting towards $4 billion that the feds have put into this mine, of which a good chunk is post receivership. So if you use a 3% or a 0% discount rate, just let things carry on, it explodes in the other direction. So you're into a project where the government, society, you and I, are putting into this mine after it went into bankruptcy in the order of $6 to $8 billion. Now, the giant mine in Yellowknife is worse than that. It's a lot more than that. So the issue is, how do we deal with this problem? This is just an example, and there are a bunch of things. There are a bunch of things that were not included in those numbers, so that we know that they're extremely conservative, and that work will get redone and refined, and people will come up with bigger numbers to tell people. But I want to share something with you and put a finger on something. I looked at what was happening in Canada with how they're going to manage the storage of used nuclear fuel. And that's a geological problem. They're going to put it in a geological repository in a very stable environment. Well, in 2002, Defense did something very interesting. They created a nuclear waste management organization, which was the development management. And they said to power producers, we would like you to start putting money in the law. It's going to set aside, and it's going to cover the costs of this management of used nuclear fuel. 2002. They were able to do that. They went to Ontario Hydro, Quebec Hydro, and Nova Scotia Power, which was the plant. And they gave them the right to add a little tiny increment on the power bill of everybody in Ontario, Quebec, and Nova Scotia who are using power going on nuclear. You don't see it in the power bill. It's not very much on these power bills. Today, here we are, 20 years later, there are $22 billion in that pot. Now, I look at that and say, that's a good idea. The money is there, people are happy that their basis is stored and taken care of. And we're going to have the resources needed when it's needed, because that is gone into a trust. It's independent of companies. It's managed by a complete independent board. It is independently audited. Governments can't dingle with it, as what has happened in other cases where trusts and heritage funds have been set up. So it seems like pretty good. Why can't the mining industry do that? Well, I'll tell you, there is a really fundamental issue facing the mining industry, and that is, well, you can do what they did on electrical power. You can't do that on the price of copper. The mining companies just can't add a bunch to the commodity because they're in an open market, competing with people all over the world. So if everybody all over the world did it, that would work. But how would you get the Russian mining companies, the Chinese mining companies to agree with the American mining companies today to do that? So it's utterly intractable right now. Now, there's some other ideas floating around that people have considered, but when you're in a project like the Faro mine or the giant mine up in Yellowknife, the amounts of money are huge. And as we stand today, governments are going to have to pick that up. But there's another change going on. And that is that 81 countries around the world now are come together in an organization called the Intergovernmental Forum on Mining, Minerals, and Metals, Sustainable Development. And the closure issue is front and center because the governments don't want to pay for this. The companies don't want to pay for it either. They've not budgeted. The community sure as hell don't want to pay for it. Nobody wants to pay for it. That's where we're sitting. So just before PDAC, the Minister of Mines from Ontario got up 3 or 4 weeks ago, said we're going to redo the mining policy in Ontario. One of the things we're going to do is that we're going to relieve companies from having to put large amounts of money up front so they can get on with the work that they have to do. Here in British Columbia, it's a big issue right now. I think the time is going to come. And of course, the environmental community, they're saying, well, hell, the companies got away with it for centuries. It's time that they pay for it. So the environmental community, they don't want to budge. And the companies don't want to pay. And the government is afraid of the money and they don't want to pay. So we're in a really difficult issue. And that's the sort of thing that is at the heart of mining and sustainability. But mining is not the only activity of humankind that has to face this sort of stuff. Just because it seems difficult, just because the boundary conditions are difficult, doesn't mean that it's impossible to solve. We need to put the resources to solve it, and we need to do it collaboratively. As long as the mining industry is throwing bricks at government, and government is slamming the environmentalists are slamming everybody else anyway, and who knows what, we're not going to get anywhere. There's got to be a breakthrough on this issue, and it may be, former Premier of the Yukon said, well, to me just a couple of weeks ago, he said, maybe we should think of something like the Workers' Compensation Board. Maybe there has to be a sharing on this. And quite frankly, because this reflects a change in values, where society has woken up and learned that we have to take care of environmental things, maybe society has to say, we'll share solving this problem. Because you know what? If we are going to make it through the transition to a low carbon economy, we're going to need mines. We're going to need the metals, and not just the critical metals. We're going to need metals in general and minerals from the mining industry. So let me see what else I got here for you. Just a very quickie thing. This is a very interesting compilation that brings together the concept of having citizens' values, ethical principles feed into the design criteria that are being used by engineers. It's the way of the future, I have no doubt. It's not happening particularly right now. Just a few little comments on some of these, and I'm not going to, I think, go through all of these. Al, you could, most of these things are from your stuff. Design life. This is a really, really important thing. I alluded to it earlier. Traditional engineering works with a design life generally for public infrastructure of a few decades, 50 years maybe. The problem with traditional engineering, and by the way, the early work in sustainable development was almost all driven by the manufacturing industry. They could see it work. Manufacturing industry, you control your inputs, you control the processes in the black box, you control the outputs. When you're dealing with natural systems that you guys are dealing with in the real world out there, you don't control it like that. There are variations and uncertainties that lead to risks that you have to admit to. And we have to move away from traditional engineering concepts where a beam can carry a certain specified load that you design and know exactly about. And the characteristics of the strength of the beam and the ability for that beam to carry that load are perfectly known. And therefore you can design it. And if the beam rusts after 50 years, we only had a 50-year time life to worry about. You pull it down and put a new beam in. Can't do that with tailings. They gotta last forever or a very long time. The concept of failure. Do you know, if you go to a traditional engineer, a civil engineer who's dealing with manufacture, or an aeronautical engineer who manufactures airplanes, they used probabilities of failure. If anything was less than 1 in a million, they'd be shocked. But when you listen to the literature, listen to the people and look at the literature about tailings, 1 in 1,000 years is kind of acceptable. So in natural systems, the really, 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 really low probabilities of failure just don't occur. And what the engineering profession has done, and this is a trick, they've concocted a phrase called engineering reliability. And because reliability is a word that's safer, people would understand that. Well, engineering reliability is the inverse of the probability of failure. So a 1 in 1,000 probability of failure is a 99.9% reliability. Well, I'll tell you, if you go to the public and say it's 99.9% reliable, that's really high. But for a tailings facility that's going to last for more than 1,000 years, when you say 1 in 1,000 probability of failure, that means sometime in the next 1,000 years, it will fail. We are designing our tailings facility with the knowledge, if people think about it, with the knowledge that they will fail. We are actually designing them to fail. Now, in the Faro case, they opted to keep this stuff in place to stabilize it. And it will have to be there for 1,000 years. And there are rushing torrents of water around it. And part of the plan is to keep those rushing torrents away from the tailings pile, because you want the water away from there. And these are in geological, unstable terrains. And one of the problems with the numbers, the financial numbers I showed you, is that they're kind of like bracketing reality so large that you don't know where it's going to sit. But the problem is that if you look at that tail on the right-hand side, nobody has done any serious study of what will actually happen geomorphologically over the next 1,000 years. That brings to bear concepts of geomorphology that we're not taking advantage of. We're not asking geomorphologists to think what actually would happen with that stuff and how much will it cost reasonably to deal with that over a very long period of time. There are aspects of the geosciences that are there to be used that we're not using right now. So sooner or later, all waste management facilities, as we have them today, are going to fail. And the engineering profession has to admit that. I had an engineer tell me one time in a debate about closure, he said, our responsibility is to put a solution on the table that the community will trust. I said, our responsibility is to put on the table a solution in which people understand the residual risks and can be part of the decision to accept or reject those residual risks. And the traditional engineers that will say, no, we're going to design a bridge that will not fall down. We're not going to go out in society and tell them the bridge has residual risks and this is what it means. But in the case of tailings, in the case of geophysical, geoscience facilities, we've got to go into this new terrain. There's a wonderful engineer whose name is Kai Lee, who worked on the dams of the Columbia River. And after many years of doing that, and after he moved into academia, he developed the concept of adaptive management. And this is really interesting if you read the fundamental papers on it. Unfortunately, adaptive management has become a buzzword to soothe people and oftentimes simply say, let's not do it today, let's watch it and do it later. Concept of adaptive management is a fundamentally different approach to engineering design. What adaptive management says is that we're going to consider this project an experiment. We're going to put in place the monitoring system and put the resources to the monitoring system to understand if and when the conditions change and what we think is going to happen doesn't happen. And so we can recognize a crisis before it comes a crisis and move to stop that. Interestingly, in the early phases of activity, the traditional engineering concepts work on the short term. The efficiency comes from effective construction and effective and efficient monitoring over the short term. But on the long term, good engineering design comes from something completely different. It comes from watching and catching the crisis before it becomes a crisis. It's a completely different mindset. And you can only, for scientists who do experiments all the time, it's a standard practice. You set up a monitoring system, so you watch. You have an hypothesis, you try to see it work, and you watch. And that concept is at the heart of the concept of adaptive management. So, again, I come back to this concept of sustainability. We're into a new kind of engineering design, and the folks with the geological training are, in my view, probably some of the best able to deal with the almost what seemingly are intractable problems today. I want to end with this list of of issues that are come out of the mining sustainability thinking process that we're really stuck with right now. And society has been stuck with problems ever since it existed. So I don't think we should shy away from these, not at all. So when mine designers optimize an extraction process, you use technical and economic analysis to do that. And you minimize the cost and you present value that all through there to come up with the right answer. One of the problems is that that is not necessarily optimum for any host community. It's optimum for the company in terms of its rate of return, in terms of being able to generate its money, get its investors taken care of so they get more money so they can do more projects. But it may not be optimum for the community. So the concept of optimizing together between mine and community is an engineering design concept which is new. Now, it manifests itself in an interesting, what if there's a big mine in the Yukon being considered right now? It's going to have about, again, a 30-year life. And there'll be employment for about 700 people on a regular basis. Most, by the way, people who come from the outside. And the question is, instead of it being a 30-year mine with 700 people employed, what if it was a 90-year mine with 100 people employed that the community then could really be part of? Well, you know what? I don't know the answer to that. And I think most mining people today would say you're crazy. But the problem is, we're not looking at it. Nobody is looking at it and doing sensitivity analysis to see the point at which the implications for the community and the implications for the company can meet so that something like that might be possible. I asked a design company, an engineering, really Vancouver-based engineering design company, mining design company, who was working on a little mine in Ireland, which was just textbook for being a wonderful project. It was going to be underground. It was the milling process was going to be underground. And I asked the consultants here in Vancouver, I happen to know them. I said, well, instead of that operation being whatever it was, 20 years long, have you done any work on what it would mean if you stretched it out so it was less of an impact on the community, but longer life? And they said, we'd love to do that. That's a really interesting question. We never thought of asking that question. The client won't pay us to do that. They want to get their money out now. And the money, the way the economic analyses are, money in hand is always more valuable than ore in the ground. It's because of the changing value of money. So these are there's tension here, but there are creative solutions staring us in the face that we're not looking at very effectively. The short-term, long-term adaptive management thing I mentioned. So if you've got a facility that has a tailings pile in it, and you're going to have to water treat for in perpetuity, whatever that means. How long is the responsibility of today's generation? We can't even imagine what it's like 1,000 years from now, let alone 10,000 years. How long is our responsibility? Well, I've thought about that. I don't know the answer, but I have a thought. What if we said that our responsibility, and this actually draws from traditional knowledge in a lovely way, what if our responsibility was for 7 generations? And the next generation, their responsibility was for 7 generations, so they rolled it up. And the next generation was for 7 generations. So it became a rolling 7-generation responsibility. What would that mean? The Nuclear Waste Management Organization that has that $22 billion pot back east, if we go to their economic analyses, they're using a time horizon of 175 years. But they know that that waste is going to be hot for 10,000 years. So they've kind of fallen into that kind of time frame. at a certain point, we cannot fathom what it would mean. We can sort of fathom 175 years. We can't fathom 1,000 years. Look back 1,000 years and think of what we learned to see what it would be like for us to look forward 1,000 years. In perpetuity, water treatment in perpetuity. We know we've unleashed the biogeochemical processes that cause that problem. And we know we can manage them to a certain extent. But we don't know. I chaired a multi-interest group of people looking at closure options of a project at one point. And we went through all the closure options. It was really interesting because there were some difficulties and pros and cons and all that sort of stuff. And what came out of it was that people realized it was a deep dive into the different closure options. And people said, well, yeah, we're going to agree on, and they did. They came to a consensus on what they thought the best way forward was. But then we all looked at each other and said, you know, the real problem is it's not the technical stuff of the closure solution. What assurance can we have that the resources to do what has to be done will be available in the future when those resources are needed? That was the concern. How do we do that? I mean, the insurance industry who deals with stuff like that, again, they're caught in decades, centuries. And we're talking about technical problems that we have to look much, much longer than that. Another problem, I don't know the answer, but we have to start thinking about that in a creative way to find solutions. And one thing I learned, it's very interesting. The federal government has 2 pots of money or 3 pots of money. I don't know how they work it. And one pot of money in the federal government is absolutely untouchable. So the money that is put aside for the pension funds of the public service, it's untouchable. It's a category, it's untouchable. There are some other things that are untouchable. And then there's all the discretionary money that the government plays with. When the federal government, and if it was participating broadly with others, should they put their part of that contribution in the untouchable side? So that people are confident. People in Canada can be confident about that $22 billion that's been set aside for the nuclear waste disposal. It is ironclad. As much as society can do it, it is ironclad. Could we do that for other environmental problems where there are call on long-term funds? Well, I don't know, but we're not asking those questions. We're caught in a 3-year, 4-year, 5-year election cycle and a need to get back investments money within a year or 2. We've got to change that. That's the security issue. And then I mentioned earlier this price issue that we've run into with the mining industry. There is a really tough problem there. And people have to admit that and not just throw bricks at each other, in my view. So there we are. Thank you very much.